And so now we're going to talk about the hardware, which is basically the part of the robot that is not the software, so not on the computer, so the physical robot itself. And to do that, I think we're going to quickly pass out the Hummingbird kits. All right, so the first thing we're going to look at in the kit is called the Hummingbird Microcontroller, which is the basis of the name for the Hummingbird kits. It's in a little silvery baggie for most of you. I will tell you one thing about the silver bag before we get digging in too far. That bag is an anti-static bag. And so what it does is it actually protects the board when it's not being used from static discharge, like you rub your feet along the floor and then you go zap someone, to a little circuit board like the Hummingbird. That shock of static is actually sort of like a little lightning bolt, and it can actually break and burn out things. So just a little word of caution for you and the silver bags and why those are important. But before I handle a circuit board, I often like to touch a big piece of metal and try to get myself de-static, whether that's like the arms on my chair or under the table, but that's just a little precaution I take. But normally it's not a problem because Tom, who has already snuck out, did a very good job designing a really robust circuit board, so it's not often a problem. But safety first for the circuit board. But yes, now go ahead and take it out of the baggie. Yes, with that tip in mind. It looks like this. It's about this big. It's not that big. So, yep. Okay. And when you're looking at the Hummingbird, there are lots of little things going on it. The first two things I want you to look for are these two lights. There's a green light. It's a little kind of a little green dome, and a yellow light, a little orangey yellow light up in the top. The orange one is the power to motors indicator. So if you have it plugged into a wall outlet properly, that should light up orange, telling you that it's ready to power your motors. Now, you don't always need to plug a Hummingbird into a wall outlet. It's also possible to just run a Hummingbird off your computer. But when you're running off a computer, there isn't enough power to power the really big motors, so you can only power like the little lights. So you can go either way on that, but if you want the motors working, or if you have motors on your robot and they're not working, check the orange light first. And the place you plug in the adapter for the wall outlet is in that little black plug right next to that orange light. Okay, everyone see that? All right, and then to plug it into the computer, a Hummingbird always needs to be plugged into the computer. It doesn't work if it's not plugged into the computer. You plug it in using this little USB connector. It's silver, right next to the green light. If the green light is on and blinking, that means you've connected. Okay? And then along with those, around the outside edge, there are all these little green blocks. These guys. And those little terminals, or ports, are what we refer to them as, are used to plug in and attach to the outputs and the sensors. So all of the components that you'll be plugging into your robot will plug in through those green ports. And if you look at the ports, you'll also notice that they're in little sets. So some of them are in groups of 3 holes per block. Some of them are 2 holes per block. Some of them are 4 holes per block. Those different numbers indicate how many wires you have to plug in for each component. So I'll show you later, but an LED is a component that has 2 wires, and so it plugs into one of the 2-hole blocks that's labeled LED. And with that, we get to actually start looking at the outputs. Okay? So the first one that I just mentioned are the LEDs. And if you look in your kit, you will find, hopefully, this big kind of rainbow-colored ring of wire that has a bunch of LEDs in it, probably in a box or in a baggie inside of your box. An LED looks like a little clear dome on the top of those 2 wires. They're very small. You can see from the pencil for scale that they're pretty petite. Yep. And just pull out one wire, one LED, so just kind of pull on the blue dome or the clear dome and you should get a whole LED with it. Now, an LED only has 2 wires. If you have 4 wires, then it's a special type of LED. So you should put that back for a moment. And so yeah, so look for one that has 2 wires coming out of it. 1 colored wire and 1 black wire. Okay? Good? Everyone has an LED? Okay, sweet. So an LED is very, I like to tell people it's like a mini colored light bulb, like a little Christmas light. LEDs light up in precisely 1 color. And you can tell what color it's going to light up from the color of the wire. So if you have a black and a green wire, then it's a green LED. If you have an orange and a black wire, it's an orange LED. And so you can tell what color the light's going to light up from the wire. Okay? And yep, and I'll show you now how to plug those in. So they plug into the Hummingbird, like I said, in one of those ports that's labeled LED. And for the LEDs, we like to represent LEDs throughout the board and the software with this little sun icon. See the sun icon? So look for that on the board, and that should kind of lead you to the ports on the Hummingbird. Oh, there it is. Sorry. And so I have some tricks for getting the wires into the ports, because they can be a little bit challenging, though once they get going, like even 5-year-olds can do it, so I have lots of faith in all of you. So what you want to do is you want to get the end of the wire and just each wire separately, so the black and the colored wire separately, and kind of twist them together into a little bundle if they're kind of frayed. You'll see if they're frayed, like all the little silver wires will be kind of going all over the place, and that kind of helps you get them in the hole nicely. And then if you look at those little green ports, there's this little square button on top. It has a little groove in it. And in each of your kits, there should be a yellow screwdriver. This is to help you save your nails. You can push that button with your finger, but I've just broken so many nails trying to push that button that using the screwdriver actually fits perfectly in that little groove. Who has one? Thank you. I normally have a little example of my own, but I didn't get one out. Okay, I'll pull these. So you want to have your wires not braided together. You want them, that's okay. Let's see. And you can take your board and you put the screwdriver just right where you want it to go. So for example, with the LED, you want the colored wire where there's a plus and the black wire where there's a minus. And throughout the entire board, if you have a black wire, it goes in the minus. Just a tip. And you can kind of push down on the button and slide the wire in. And then when you release the button, it kind of grabs a hold of it. Stick it in, let it go, and it kind of grabs a hold of it. So then when you give the wire a gentle yoink, it won't come out. Let me think, anything else? I think that's everything you know about LEDs. When you're sticking the wire in, if you're having trouble doing that, when you look at how the hole is, it's actually kind of going in at a 45-degree angle. So if you're trying to stick it in horizontally or vertically, it's not going to work for you. So try to go in at that angle. Okay? Awesome. Okay, so next up, if you found one of those special LEDs that has 4 wires coming out of it, that's what we're going to be looking at next. There's also one on your mini-bot. So if you look at your mini-bot, there should be a little bundle of black, red, green, and blue wires coming off of it. Okay. You can connect the mini-bot. That would save you a step later if you wanted. Tricolor LEDs are just like regular LEDs, except they have 3 different colors inside of them. And that allows you to make your tricolor LED into a green LED or a blue LED or a magenta LED just by mixing those different colors together. And I tell people it's kind of like the little pixels on your television or computer screen that you can light up red, green, and blue and make different combinations of colors. So, and everyone always asks, how do I get yellow? None of those are yellow. And when I learned how to mix paint when I was younger, I learned that you need yellow and blue to make green, but there's no yellow. And with lights, it's actually different. To get yellow, you mix red and green, and that turns yellow. So lights are a little bit different from paints. Okay, and they plug in under a port with this little sun symbol that has the 3 divisions in it, representing the 3 different colors of the LED. There are 2. You have 2 tricolor LEDs. And kind of for how to plug it in, red goes in R, G goes in green, B goes in blue, and minus, like I said, is always black. I promise the more you put them into the ports, the faster it'll go. You'll be little speed demons in no time. Okay, well, I'm going to talk about the next output while you guys are finishing that up. The next ones are servo motors. They're these big black motors that are on top of your mini bots. You can see the black box with the little white disc on it. That's a servo motor. Inside of your kits, they're either kind of floating around or they might be in their own little individual boxes. So you're welcome to try to find some in your kit. You should have 2 to 4 in your kit. The full kit that you would purchase from Tom would have 4 in it, but these kits we reuse every workshop, and so some pieces get used up over time. So a servo motor might become your favorite output. It's one of my favorites because you can just use them for everything on your robot. I use them for actuating the jaw of my dragon and turning his neck. And what they do is they actually behave somewhat like your elbow in that you have really good control of the position of your arm, but you aren't able to like rotate your arm around 360 degrees. So you get really good position control, but you give up the ability for the motor to spin around and round like the wheel of a car. So we'll be using those a lot in a little bit with the mini bots, but the mini bot has one that allows it to point this little light baton in different directions and kind of wave to people. And so that's what servos do. And they're the easiest thing to plug into the Hummingbird because you actually do not put them in a green block. You actually plug them in onto this little set of pins in the bottom corner. There should be a set of 12 pins. And the yellow wire on the servo connector plugs in to the pin column that is labeled with the S. Okay? And you want to make sure when you're putting on the servo, it's really easy to put it on crooked or off by 1. You want to make sure that you're going across a row of 3 and that you're covering all 3 pins. You don't want it vertically across the column of 4 and missing 1, or like shifted by 1, and so that 1 pin is uncovered and 1 pin isn't connected to your servo. So the black kind of goes towards the outside edge and the yellow goes towards the middle of the Hummingbird. But they're really easy to plug in once you get them on straight. Next up are the regular motors. Regular motors are the ones that more people think of, like on the wheels of a car. They can just spin around and around in circles, electric fans, lots of those electric motor things that can just continuously spin. And they're really nice for making spinning objects, but the problem is they can't control the position. You can't say, with the servo, you can say, go to 90 degrees, go to 100 degrees, go to 0 degrees. With this, you can just say, go forward, spin backward. So it can either spin clockwise or counterclockwise, and you control the speed that it's spinning at, but you have no control over what direction something that is attached to it is pointing. Some students like to try to do that. They like to put like the hands of a clock or something on the motor. And it works, but you have to be very careful about timing. You have to say on for 1 second and then off. On for 1 second and then off to get it to have the right angle movement. So it's a little more challenging to use, but they're good for certain applications. And motors have 2 yellow wires, and lucky us, that means that you don't actually have to put them in to their motor block in any particular way. You can put either yellow 1 in plus and either yellow in minus. The only thing it changes is what direction the motor spins.
When it's spinning clockwise and it's not doing it, you switch the wires.
Yep. And in the software, you can actually control it spinning forward and backward. It's just whether forward means clockwise or forward means counterclockwise. So it's kind of changing how the software perceives the motor. What is that? Those are not the motors. Nope. Well, we will do that shortly. Yep. Okay. And the motor is represented by this little, continuously rotating arrows to represent its ability to rotate 360 degrees. Has everyone found where that plugs in? Yep. Okay. Well, if you don't say stop, I'm going to keep going. So the last output that we're going to look at is the vibration motor. It's really, really small. You can kind of look at the pencil and see how little it is. It's either going to have a little green rubber jacket on it, or it'll just be a little silver cylinder. It'll have two yellow wires coming out of it. Sometimes they get mixed in with the LEDs. Let's see if I can find one for someone here. Hold it up. They're kind of hard to recognize if you don't. Yeah, I bet yours is right there. Okay, here we go. This big, very small. The little green casing is nice. It makes it easier to glue things to them, but they tend to fall off. So if you don't have it, that's not a problem. So don't worry if you're missing the green rubber. And vibration motors are basically the exact same thing that would be in your cell phones when it's in vibrate mode. So they cause that little slight buzzing tremor when the motor spins. And they have on them, you'll look at the end and see there's a little kind of half-moon shaped pendulum at the end of the motor that you can kind of spin around with your finger. That's a little weight that when it spins really fast, it sort of causes the center of mass of the motor to shift up and down, which is what causes the vibration. And so what you want to do is when you're working with students always like to glue things to that little weight. Like I've seen so many leaves glued to that weight. But this motor is very small and it's very weak, and so it can't actually like spin the leaf around. That's not how you make things vibrate with this motor. You actually glue the motor itself to the leaf, and you make sure that the little weight, the little half-moon shaped metal that we're talking about can spin freely, so it's not bumping into anything. And that's how you get something to vibrate really well. And when you're using it, you also have to think about how small that is, how small and lightweight that motor is. So it also has a lot of trouble moving really big things. So I actually messed up and I put them on these dragon wings on my dragon. So you can kind of see they're right here in hot glue. And they're actually so weak that they can barely move the dragon's wings, like hardly at all. And so you want to normally glue your vibration motor to something that's very lightweight, like a bell or a feather or a leaf, something that's light. Okay? And then they'll vibrate really well. Okay, and those plug in, it says a motor, but it means vibration motor, in these blocks that are marked with this little wiggling rectangle, and that's how we indicate vibration motors. And once again, just like the motor, it doesn't matter if you put which order you put the wires in. Okay, so now we're going to talk about sensors, which are the other things that are in your kit, the only things that are remaining. And while I'm talking about sensors, I'm not actually going to give you a lot of time to plug each one in because they all plug in the exact same way, okay? So once you know how to plug in one sensor, you'll know how to plug them all in. So sensors plug in to these ports along the opposite side of the Hummingbird, along the top side, that's labeled sensors, and it has this little rectangle with an arrow coming in, which indicates the data from the sensor coming into the Hummingbird. And there are 4 sensor ports. And you'll notice you have 5 different sensor types, and you can put any sensor in any port. And like I said before, the black wire goes in minus, the red wire goes in the plus port, and S is the yellow wire. Okay? Okay, so now for different types of sensors. The sensors are kind of obviously named. So there's a light sensor, and it senses light. In particular, it can sense how light or dark it is in a room. So it can't tell you what color the light is, and you can't like flash SOS at it, but it can tell, if it's really bright or really dark. And I always tell people you can actually see these in night lights. Like if you go in your house and you have one of those lights night lights that plugs into an outlet, if you look at the top, you can often see a light sensor on top of it. And they almost always look like the same. They're these little white discs, very small, with a little brown squiggle on top. The next one we're going to look at is the temperature sensor. The temperature sensor, believe it or not, is even smaller. And it is used, as the name would imply, to sense the temperature in a room around it. You'll often see it in digital thermostats so that it can tell how hot it is in your house, when it should turn off the heat. And temperature sensors have this very small little black nub at the end of them. And the black nub is actually where the temperature sensing happens. So you'll see students rubbing ice cubes up and down the length of the wire, not getting anywhere because it's actually sensing at the end. And another important thing to go along with the ice cubes is that these are not waterproof. So like on their own, they're not waterproof. So generally, if you're a science teacher and you want to be dipping it in boiling water, I tell people the easiest thing to do is to just cover it in hot glue. So you just however you would waterproof something, you stick it in a Ziploc bag and then stick it into ice water. You can cover it in hot glue and stick it into ice water. You just don't want to get water into this little black tubing at the end. The next sensor is my personal favorite sensor, which is the distance sensor. It looks like a little robot face with two black beady eyes. I have one here at the front of my Dragon. It's kind of hard to see because it's built into the Dragon. And a distance sensor, to get a little technical, is it shoots out an infrared light that you can't see out of one of those eyes. It bounces off the object in front of it, and it comes back in, and the sensor can actually tell what angle that light comes in at. And if you remember your trigonometry, that can kind of tell you how tall the triangle is. So it's pretty cool. But also, I tell students that when you have a distance sensor, you don't want it to be a pirate. You don't want it to cover either one of those eyes, because then it'll stop working and it loses its depth perception just like you would. So it's a true fact there for distance sensors. But they're really great otherwise. They can see measured distances between 3 feet and 3 inches in front of the robot. So as you walk up to your robot, up to my Dragon, it can slowly change what behavior it's doing. So it's pretty neat. I like to use them. And you can see these in our automatic soap dispensers. If you go to one of the bathrooms here, we have them automatic toilets and paper towel dispensers. So they're very common now, distance sensors. Potentiometer is the only sensor that doesn't have the word sensor in the name. Potentiometers are little knobs that as you turn it, the sensor can tell to what angle you have turned it to. So these are good for robots where as you slowly turn up a knob, like the lights do something, or they can work as an on and off switch for your robot. And this is once again where we're talking about sensors not sensing the environment, but sensing what a human is doing. Oh, and they have they're this big brown thing with the silver line coming out of them, metal column. And you twist that metal piece that's popping out of them. And finally, the last sensor is a sound sensor. Once again, it's not like a microphone. You can't speak into it and say, hello, robot, like Star Trek, hello, computer. It doesn't work. It measures the volume of a sound in a room. So you can use it like the clapper and kind of, I've also seen librarians use it to make something that like raises its hands when it gets too loud in the library or something. So you can make different things that can tell how loud it is in a room. In the cafeteria, if it starts getting too loud, you get a robot that starts, jangling bells and blinking lights. And that is all the sensors in the